Hello everyone. In today's class, we'll be discussing about 0-1 knapsack problem using dynamic programming. Let's see what is meant by this 0-1 knapsack problem. Introduction part. So we are given the following. We are given a knapsack. A knapsack is nothing but a bag with a certain capacity. A knapsack with limited weight capacity. It can be anything. It can be 10, it can be 5. So there is a certain bag with a certain weight carrying capacity. And we also have a few items. Each of those items have a certain weight and value. Each of those weights have a certain weight and value. And we also have a knapsack or a bag which has a certain weight carrying capacity. So we have to fill those items in that knapsack in such a way that the value or the profit obtained by those items have to be maximum, but the weight of those items which are added into the bag should not exceed the capacity of the knapsack. Alright, we'll see an example. I have a knapsack over here. The weight carrying capacity of this knapsack or this bag is 15 kgs. So the maximum weight that this bag can carry is 15 kgs. I have 5 items over here. There are certain weights and values or profits associated with these items. Now I need to add these items into the bag in such a way that the weight should not exceed 15 kgs, but the profit obtained by these items have to be maximum. So how do I do it? One more thing we need to remember about this 0-1. 0 refers to we either take the object, 0 refers to we do not take the object, and 1 refers to we take the object. So either you pick the object and place it, or you do not pick the object and place it. We cannot pick fractional objects and place them into knapsack. Right? As the name suggests, the items are indivisible here. That is why 0 and 1. You either pick the object or you do not pick the object. We cannot take any fraction of any item. We either have to take an item completely or leave it completely. When we take it completely, it is 1. When we leave it completely, it is 0. So this problem is solved using dynamic programming approach. So we'll be using the concept of dynamic programming. We'll be dividing the problems or we'll be getting solutions to sub problems, and out of all those solutions that we get, we're going to choose the most optimal solution. All right. Alright, so what are the things that will be given to us when we solve this 0-1 knapsack problem using dynamic programming? First, the knapsack weight capacity W will be given to us. Then the number of items each having some weight and value N. We'll be having N objects or N items which will be given to us. We'll also be provided with the knapsack weight carrying capacity that is indicated by W. We'll also have the weights and the profit associated with each of those objects or items. So we need to follow certain steps in order to solve this using dynamic programming. The first step is that we need to draw a table. Say draw a table T with N plus 1 number of rows and W plus 1 number of columns. So this N plus 1 is the number of items, W plus 1 is the capacity of the knapsack. Say we have 4 objects or 4 items, then it's going to be 4 plus 1, 5 rows, and say the knapsack capacity is 8, then it is going to be 8 plus 1, 9 columns. 8 plus 1, 9 columns starting with 0. So if we have 4 objects, it will be 0, 1, 2, 3, 4. If we have the knapsack carrying capacity is 8, then it will be 0 to 8. So we'll be filling this entire table using this formula. We'll see that formula later on. We'll see how to fill that table logically. We'll take the number of objects with their profits and their weights and we'll fill that table. So an example that we'll be taking is knapsack capacity, that we'll consider it as 8. So only 8 kgs is the maximum capacity of that knapsack. The number of items that we have is 4. The weights of the items are 2, 3, 4 and 5. You can call them 2 kg, 3 kg, 4 kg and 5 kg. The profits associated with these items 1, 2, 5 and 6. You can call them 1 rupee, 2 rupee, 5 rupees and 6 rupees respectively. Let's see how to fill that table. So either in the examination this is what will be given to you, or a table like this will be given to you. This is item A, the weight of item A is 2, the value or the profit is 1. This is item B, weight is 3, value or profit is 2. Item C, weight is 4, value is 5. Item D, weight 5 and value 6. So using this, we'll be solving this knapsack problem. The capacity of the bag is 8. Right? So let's see how to solve it. The first step is that we need to draw a table with n plus 1 rows and w plus 1 columns. So w is equal to 8. This is knapsack capacity. This is the knapsack capacity. N is equal to 4. So n plus 1 rows, so 5 rows I'll be having. So 0, 1, 2, 3 and 4. 0, 1, 2, 3 and 4. Then I'll be having 8 plus 1 columns. 3, 4, 5, 0, 1, 2, 3, 4, 5, 6, 7, 8. So 9 columns and 5 rows. This is n plus 1 rows and w plus 1 columns. So draw this table in this fashion. And now we'll be going on filling these values and we'll try to find the maximum profit that we get in this table. So we'll be going step by step. First we'll add 1 object, 2 objects, 3 objects and then 4 objects. Initially the bag is empty. At first the bag is empty. So fill first row and first columns with 0. This is the first step. Initially the bag is empty, which means there are no objects added. When there are no objects added, there is no weight and there is no value. So that is why the first row and first column is added as 0. So weight and profit. So for object 1, what is the weight of object 1? 2. What is the value? 1. What is the value or profit? 1. So you can just write it down here. So it will be easy for you to fill the table. The second item, weight is 3, value is 2. Weight is 3, value is 2. The third object, weight is 4, value is 5. Weight is 4, value is 5. The fourth object, weight is 5, value is 6. Weight is 5 and value is 6. Right. So you can call it PI and WI. Okay. So now we are going to fill all these tables based on these values that I have. The weight of the object and the profit associated with that object. So the first object. Now I'm going to fill the first object inside the knapsack or inside the bag. Let's see how to do this. So when I fill the first object over here, I will not consider the remaining because I'll be filling only one object, that is the first object. Okay. What is the weight of the first object? It is 2. So when the knapsack capacity, this is the knapsack capacity, W. When the knapsack capacity is 2, I'll be able to fill the first object. What is the profit associated with that object? 1. So at knapsack capacity 2, write the value 1. Write the value 1. So previous value will be 0. Previous value, whatever is there, write it 0. Now, what about the remaining cells? What about the remaining cells? Here the knapsack capacity goes on increasing. The knapsack capacity is going on increasing. 3, 4, 5, 6, 7, 8. But how many objects have I added? 1. I'll be adding only one object. So the remaining cells also will be 1. Remaining cells also will be 1 because I have added only the first object. Let me repeat it again. I'll be adding the first object. So when I'm adding the first object, I won't be considering the remaining 3 objects. What is the weight of the first object? 2. So I'll be able to add this first object when the knapsack capacity becomes 2. So in this 1, 2, what is the profit of the first object or value of the first object? 1. So add 1 over here. Remaining will be also filled by 1 because even if the knapsack capacity goes on increasing, I have added only one object. So that is why fill the remaining with 1 and before 1 fill it with 0. Alright. Next, I'll be adding the second object. So when I add the second object, I should consider the first object as well. Let's try to add 2 objects into the bag. First object and second object. Let's see if we can add. Let's first consider the second object. What is the weight of the second object? 3. So when the knapsack capacity becomes 3, I'll be able to add the second object. What is the profit associated with the second object? 2. So at knapsack capacity 3, I'll be adding 2. The profit of that second object. Just retain the previous values as they are. Now what about the remaining? I am adding 2 objects now. Object 1 and object 2. If I add these 2, what will be the weight, total weight of those 2 objects? If I add object 1 and object 2, I need to consider their total weight. So what is the total weight over here? 3 plus 2 is equal to 5. The knapsack capacity is 8. So I'll be able to add these 2 objects when the knapsack capacity is 5. So I'll be able to add them here. What are the profits associated with these 2 objects? 2 plus 1, 3. So at this cell, put the value 3. Retain the previous values. What about the remaining? 3. Because my maximum capacity is 3 over here. Only 2 objects I am adding. When I add 2 objects, maximum weight that the bag can handle is 5. So remaining, keep them as they are. Next one. I'll be adding 3 objects. First, second and third. Let's find out where they fit. First, second and third. First I'll add the third object. What is the weight of the third object? 4. So when the knapsack capacity becomes 4, I'll be able to add the third object. What is the value of that third object? 5. So wherever there is knapsack capacity 4, add its value 5. Add its value 5. Previous values, keep them as they are. Next, what if I add first, second and third object at a time? Can I add all the objects? Let's find out. 4 plus 3, 7, 7 plus 2, 9. What is the capacity of the bag? 8. So I cannot add all the 3 objects. I cannot add all the 3 objects into the bag. Can I add these 2 objects? 4 plus 3 or 4 plus 2. Can I add the first object and the third object? What will be the total weight? 4 plus 2, 6. Yes, I have knapsack capacity 6. So first object and third object. What is the total price or value associated with these 2 objects? 5 plus 1, 6. So knapsack capacity 6, value will be 6. Can I add these two objects, second and third? 4 plus 3, 7. Yes, knapsack capacity 8, so I can add these two objects at the 7th cell. What is the value associated with them? 5 plus 2, 7. Previous, just retain as it is. Just retain as it is. Here it will be 7. Here it will be 7. Similarly, do it for the third one, or the last object, the fourth one. I'll try to add all the 4 objects. Let's see if they fit. I can add the 4th object first. First I'll add the 4th object and check. Knapsack capacity, the weight of the 4th object is 5. So wherever there is 5, add its value. What is the value of the 4th object? 6. So at knapsack capacity 5, it is going to be 6. Next, can I add all of them into the bag? 9, 10, 11, 12, 13, 14. No, I cannot add all of them, because if I add all of them, the total weight of those objects will be 14, whereas my knapsack capacity is 8. So I cannot. Can I add 4 plus 3? 7. Yes. What is the value? It is 7. So at 7, I'll be adding 7. What about 8? 5 plus 3. Can I use this 5 plus 3? This second object and last object? Yes. 5 plus 3 is 8. Knapsack capacity is 8. What is the value associated with those two items? 6 plus 2 is 8. 6 plus 2 is 8. Retain the previous values as they are. Retain the previous values as they are. So this is how you fill the knapsack table. I hope this is clear to you. Now, last row and last column value. Last row and last column value. This is my maximum profit. This particular cell, 4, 8, it is going to give me my maximum profit in that knapsack. So let's find out which are the objects that we can include and which are the objects that we cannot include with respect to this. So I'll call them x1, x2, x3 and x4. So I'll call them x1, x2, x3 and x4. So when I include any object, I'll denote it by 1. If I exclude any object, I'll denote it by 0. So I'll follow the same terminology here. What is the maximum profit that I've got? 8. So this 8 maximum profit, we got it by adding object number 4. We got it by adding object number 4. So include it. The profit has to be maximized. This is what is the solution, or this is what we need to have. Maximize the profit without exceeding the limit of the knapsack. So this maximum profit 8, I have got it by including object number 4. So include it. What is the profit associated with object number 4? 6. So it will be 8 minus 6 is equal to 2. This is our remaining profit. This much is still remaining. I can still add this much. 8 minus 6 is equal to 2. I have got this 8 by including the 4th object. But what is the profit of the 4th object? 6. So 8 minus 6 is equal to 2. Now check for the value 2. Check for the value 2. Where is it present? Is it present in the previous row? Yes. Is it previous in the row before this? Yes. Which means that we haven't got this value 2 with the help of object 3. Go to the next. Is 2 present in the previous row? No. Is 2 present in the previous row? No. Which means that we have got this 2 by adding object 2. we have obtained this 2 by adding object 2. So include this. So include this. What is the profit of object 2? What is the profit of object 2? 2. So it is 2 minus 2 is equal to 0. Is 0 present in the same row? In the previous row? Yes. Is it present in the previous row? Yes. So don't include this. So first object and the third object will not be included. So which are the objects that are included? Second object and fourth object. Second object and fourth object. So mark them. What is the total value? What is the total profit then? So total profit by including the second object and the fourth object, it is 2 plus 6 is equal to 8. Knapsack capacity 5 plus 3, 8. So what is the knapsack capacity? 8. So hence we are not excluding the knapsack capacity and we are also maximizing the profit. So when you include the second object and the fourth object, you will get the maximum profit. I'll explain this part again. X1, X2, X3 and X4. These represent the 4 objects. This value or the value in this cell gives me the maximum profit that I can attain. So this value 8, how have I obtained it? I have obtained this value 8 when I included the fourth object or the fourth item. So include it. Is 8 present in the previous? Is 8 present in the previous row? No, it is not present. So include it. Which means that I have got this 8 by including the fourth object. What is the profit associated with the fourth object? 6. So hence I'll make it 8 minus 6 is equal to 2. That is the remaining profit that I have, that I still have. Next, search for this 2. Is 2 present over here? Yes, it is present. Check whether it is present in the previous row. Yes, 2 is present in the previous row, which means I did not get this 2 by object number 3, by adding object number 3, so exclude it. 2 is present over here? Yes. Is 2 present in the previous row? No, which means I have obtained this value 2 by adding object number 2. So add it or include it. What is the profit associated with object number 2? 2. So 2 minus 2, 0. Is 2 present over here? Yes. Is it present in the previous row? Yes, which means I have not got 0 by including the first object and neither the second object. So exclude the first object. Exclude the first object. So which are the objects included? Object 2 and object 4. Object 2 and object 4. So hence, what are the values of, the profits associated with 2 and 4? 6 plus 2 is equal to 8. So this is how you solve the knapsack problem. Here the profit is maximized. If I add these two, the profit will be 8. What is the weights associated with these two objects? 5 and 3. So 5 plus 3 is equal to 8. The knapsack capacity is also not exceeded, and I have also got maximum profit out of it. So this is how you solve a knapsack problem. So this is one way of solving it without the formula. This is one way of solving it without the formula. Let's apply the formula and see. So this is the formula that I have. Let's apply it to this last one. So I'll just calculate these 3 cells and I'll show you how it is done. These 3 cells. So what does it say? T of ij, T of I comma j is equal to max of, T refers to the table. max of t of I minus 1 comma j, t of I minus 1 comma j, comma value of I plus t of I minus 1 comma j minus weight of I, minus weight of I, minus weight of I. Let's substitute values. Which is this cell? 4 comma 6. So t of 4 comma 6 is equal to maximum of t of, what is the value of I? I value is 4, j value is 6. So 4 minus 1. 4 minus 1 is 3 comma 6 comma value of I. What is the value of the fourth object? 6 plus t of I minus 1, 3 comma 6 minus weight of I. I value is 4. What is the weight of the fourth object? 5. Substitute these values, see what you will get. So max of t of 3 comma 6, t of 3 comma 6. What is 3 comma 6? What is the value of 3 comma 6? 3 6 is 6 comma 6 plus. So 6 plus 3 of 6. What is 3 of 6? 6 minus 5. So what will be the value? Max of 6 comma 6 plus 6 is 11. Sorry, 12. 12 minus 5, 7. 12 minus 5 is 7. So what is the maximum of 6 and 7? 7. What is the value of 6, maximum of 6 and 7? It is 7. Similarly, substitute the value for these two cells and you will get these values. So you can either use the formula for the entire table or you can employ the technique which I have shown. That is the logical way of doing it. This is using the formula. Any one of them is fine. You can either use the formula like this, which is a very safe method. You will get exact values. That will also give you the exact values, but you need to be very careful while calculating here the weights and profits. So the choice is left to you. Either use this formula or you can use the method that I have shown. So this is how you solve 0-1 knapsack problem. 0 refers to you do not pick the object. 1 refers to you pick the object completely. You cannot pick fractional objects, which means that those objects are indivisible. So they are solid objects. You can say a mixer, a microwave oven, a television. Okay, so all these objects are indivisible objects. You cannot carry a half television or a half mixer. So it's like that. That is why it is called 0-1. You either pick it completely or you do not pick it. Fill the knapsack such that the weight of the knapsack is not exceeded and also you get maximum profit. So in this example we have seen 2 and 4. These are the two objects that we can pick. The knapsack capacity also doesn't exceed and also we have got maximum profit. So employ this technique for any of the problems given and solve 0-1 knapsack problem. So this uses dynamic programming. So what does dynamic programming say? We have to make a sequence of decision at every stage. We have to make a sequence of decision at every stage. So at every stage I am making decisions over here. Should I include all the items or not? Should I include the first item? Should I include the second or no? Third or no? Fourth or no? Should I include all the items present? Should I include the first and second or third and fourth and so on? So I am making a sequence of decisions and at every point in the decision I am picking the optimal solution. So this is what dynamic programming helps us in solving. So there is also a greedy method of solving a knapsack problem where we can use fractional objects. Here we did not use fractional objects, there we can use fractional objects. So take any example, draw a table like this, fill its values and check. Either you can use the formula or the technique which I have shown. So in the next class, we'll be studying about the greedy method of solving knapsack problem. Thank you.